3 out of 4 healthcare.gov customers can find a plan with a monthly premium of $50 or less thanks to financial help. These quality plans include coverage for doctor visits, preventive services, and prescription drugs. Sign up at healthcare.gov through May 15th.
Well, let's get started then on your first day of Calculus 2. And like I said, we're going to start with section 6.1. And we're going to talk about the natural log function. You know, I know you guys have seen the natural log function before, but it's probably a good idea to go over some of the properties, because you might have forgot them. We haven't really worked with them a lot since maybe your pre-calculus class, maybe your Math C class when you get it for the first time. So we're going to start with some of the properties, what you can and what you can't do with natural logarithm and with log functions in general, and how that's going to help us with our derivatives and some of our integrals. So let's talk about the properties. The first one. First one is kind of a nice one. Anytime you see this, you loved it because it meant if you had ln of 1, that was always equal to... Say it again?
0.
Yeah, it's exactly right. So what this is, if you don't remember how logarithms work, logarithms say a base. What's the base here?
E.
E is. E is the base. For any logarithm, you don't need to write this, but check this out. If we had this, for instance, this would be our base, that would be our power. Base to the power gives you the argument of the logarithm. So this would have an exponential notation. Like that. If you forgot all about logarithms, that's like a really crash course in logarithms, okay?
Your playlists are a fuego because you rock and roll and reggaeton.
And I feel better now. Do, 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 do.
You could do, if you don't like the over 12, you could do 1/12, you could do minus 1/16 of 2x plus c. You could factor if you really wanted to, but this is what I'm looking for from you. Show of hands if that actually made sense. Is it that hard? No, but here's the thing. The math here, I promise you, it's not hard. It's just you got to follow the steps, like precisely, and you got to be able to identify what case you're working with. The first step here is the hardest. Not the hardest, it's the most important. So the first step in doing this correctly is really, really key for you to get the correct answer here. If you strip off the wrong thing, it's going to take you either 10 times longer or it's not going to work out for you. All right, so let's get started. So what we're working on, we're going to continue working on some of these trigonometric integrals. And yeah, they get pretty hairy, but we have some cases, some ways to deal with these things that make them at least a little bit nicer. We have a technique, a method to go through this. So let's consider some of these. We'll gradually make them a little bit more difficult so you can see some different ideas that we have to work with. Let's look at the integral of sine cubed x cosine squared x dx. Now, I gave you some cases. What I said was there's really two of them. Either you have at least one odd power or you don't. If you have case one, if you have at least one odd power, the goal is going to be split off either a sine or a cosine of that odd power and then use a Pythagorean identity. If you can use a Pythagorean identity, you change it from sines and cosines to either all sines or all cosines. Does that make sense? That's the idea here. So I want you to get familiar with what you're doing. Don't just follow this like a pattern. Really understand what we're trying to do. We're stripping off one of these things, firstly, so that we can make a Pythagorean identity substitution, substitution, and then we'll have all of one type of function, either sines or cosines, with the exception of that one thing we stripped off. The reason why we need that one thing we stripped off is because then a regular u substitution will work really, really nice. So let's look at our problem. Do we have an odd power? Are they both odd?
No.
Okay, so if one's odd, that kind of makes our choice easy as to what we're going to do. If there's one odd, we're going to strip off one of those factors, and use the Pythagorean identity. If they were both odd, we typically pick the smaller power because that will usually give us a Pythagorean identity easier. Does that make sense to you? So, for us, what are we going to pick for the thing that we're stripping off here, sine or cosine? And why are we picking that? It's odd, and if I strip off the sine, I'm going to get sine squared. That's the Pythagorean identity I'm looking for. So here, we're going to write this, and I typically write it this way. I'll write my sine squared x first, and then then my cosine squared x, and then I'll put my sine x at the very back. Whatever you strip off right there, you put it at the back. And the reason is because what's going to happen, again, the idea here, use this to get a Pythagorean identity. That way sines become cosines, these will all be cosines, and then I can make a substitution. Hey, what's the derivative of cosine?
Oh, sine.
Sine, yeah. So that's the idea, is we're trying to get to that. We're trying to get back to this going away. So, by the way, some people ask at this point, well, wait a minute, why don't I use the Pythagorean identity on this one right here? Well, if I do, then I'm going to get sine to like the 5th power somewhere, and that's not a good thing either. We want to be able to make that substitution and get rid of this. So, as soon as we get our odd power, we strip off one of the factors. Then we go ahead and say, well, the method I gave you said change one of those things by the Pythagorean identity. Whatever you stripped off, that's what you're left with. So this thing is going to be, what is it? Yeah. The rest of this stuff is still here. The rest of that is right there. Quick head nod if you're okay with it so far.
Yeah.
If you're going, well, now why does that help us? Well, why it helps us is because right now I don't want you to distribute. That'd be silly, okay? Because this whole thing would have to go here and here. You'd have two integrals instead of our one. We want to make this easy. Right here, if I do a substitution on cosine and make this u and make this u, what's the derivative of cosine again?
Sine.
Negative.
Close. What is it? That's going to go away. Yeah, my integral is going to change to a negative, but that thing's going to go away. Does that make sense? This is the idea. If you have an odd power, break off one factor. Use an identity, make a substitution. That's how it works often with this stuff. So here we go. Wow, this is really nice. As soon as we see this, don't worry about distributing or anything, because if we do a basic substitution for cosine, do I want cosine squared or just cosine? What do you think?
Cosine.
Yeah, just cosine. If I have cosine squared, I got to do the chain rule, and that's really annoying because I'll have cosines and sines coming up at us, and we don't want that. So du equals negative sine x dx. When I'm doing my my substitutions on a lot of these trig integrals, I won't solve it for dx. I know I showed you that sometimes I don't. What I typically do is just move this sine or any constants over. So negative du would equal sine x dx. Because, and this is why we put this at the back end. Do you see how this piece matches up perfectly with that piece? You guys see what I'm talking about? That's what we want. So I move this at the back end because this is now a really nice, easy substitution right there. Okay, so why don't you tell me what's going to be on the inside of our integral now? What do we
1
got?
minus u squared.
Okay, good. We got the 1. Minus what now?
U squared.
Cool. Cosine is u, so cosine squared is u squared. Excellent. What else?
Times u times sine x.
Times u times what?
Sine x.
U.
Oh, no, du now. We got rid of the sine x.
U squared. Okay, so we got 1, I got minus, I got u squared, I got another u squared.
du.
There's something a lot of you love missing. What are you missing right now?
Negative du.
Oh, besides that.
Parentheses.
Missing parentheses. That's important. Why is that important?
So you know.
For some reason, some of you guys have the tendency to miss parentheses and still distribute because in your head you like know they're there or something. It's really important for you to put those. You need them to say this is what I'm doing. Otherwise, this math kind of falls apart. You need to show that. So these parentheses are not trivial. And then, now, sine x dx is the same thing as what?
Negative du.
Okay, we don't want to forget the negative du. So times negative du. What are we going to do with this thing right now? What do you think?
Well, negative out.
Hold the negative out. Okay, so negative integral. What else are we going to do?
Distribute.
That will be u squared minus u to the 4th. Don't forget the du. Don't get sloppy with this integration. You got to show all this stuff. None of it is trivial. You guys okay with this so far?
Yeah.
We just changed a really nasty integral. And we go, man, how am I going to do that? Something really, really easy. This is brilliant. This is nice. So we'll have negative. What's the integral of u squared?
U third over 3.
Minus what?
What is that? U to the 5th over 5.
Would it be positive?
Well, you tell me. What am I having wrong here?
Now you gotta distribute the negative.
Okay, so if I don't have my brackets, then this is wrong. If I do have my brackets, then we have negative u cubed over 3 plus u to the 5th over 5. Naturally, you could write this in the reverse order. Might be a little bit nicer to do u to the 5th over 5 minus u cubed over 3. Now, we don't want to stop there. What's the next thing we got to do?
Plug your u back in there.
That's very good. So whatever our u is, we'll have, and I'm going to reverse this right now. So I'll have cosine to the 5th power of x over 5 minus cosine to the 3rd power of x over 3 and plus c. That's the idea. I'm wondering if that makes sense to you. By show of hands, can you show me if that does? Easy, medium, hard, what do you think?
That was alright.
Kind of medium, right? This part, as soon as you see this is easy. This should be easy at least. This part is the part that people struggle with. Like, how do I do it? You got to get used to seeing these things, following the pattern. You know what I mean? That way you go, okay, hey, look, that's an odd power. That's an even power. I'm going to strip off one of those things. That's the idea here. Shall we do another one?
Yes.
So far I think I've given you 2 odds and I've given you 1 odd. Let's see how it works with this example. You know what, I'm gonna need some more room. Do you have any questions on this? Because I'm gonna erase it. Some of these things take a while, so. Okay, so now we're going to do sine to the 4th, cosine to the 4th. So as soon as you see this problem on a test, yes, you're going to have something like this on a test. As soon as you see this on a test, you go, all right,
I've been a
cool.
member of the IIT
How in the world are we going to do that? Well, go through the pattern. Do we have at least 1 odd power? Okay, so they're both even. If they're both even, the idea of Pythagorean identity goes out of your head. Because if I do this, if I strip off either a sine or a cosine, I'm left with an odd power. Does that make sense?
Yeah.
The Pythagorean identity is not going to work with an odd power. Your substitution won't work because you'll have an extra sine or an extra cosine somewhere. That's not a good idea. So if you have both evens, the idea is you're going to manipulate this thing a lot. It's going to be a lot of work. But what we're going to be using here is the half-angle formulas, where we have sine squared equals 1/2 1 minus cosine 2x,
Yeah.
and cosine squared equals 1/2 1
plus
plus cosine 2. Very good. So we're going to be getting down to those things here in just a minute. So let's work on how we might go about doing this. And there's a few ways to do it, okay? So here's what I do. If I'm working on this problem, the first thing I'm doing is I'm going to try to make this either all sine or all cosine. If I have the same power like 4, 4, we can typically do this. Check this out. Well, I could make sine x, cosine x, all to the 4th. Is that true?
Yeah.
Sure, I could do that. My idea right now is to combine my sines and cosines with some sort of an identity. Right now, if you don't know it, I can actually do that. So if I'm looking at sine x, cosine x, I'm going to use this identity over here. Do you know this one?
Sine x to,
2x.
Do you guys know that one?
And that times cosine 2x too?
No.
That's the right one. Do you guys know that one? Double angle?
No.
Okay. Well, check it out. We can manipulate identities all the time. If we know they're true, we can manipulate them. So if I take this thing looks a whole lot like this piece, don't it?
Yeah.
Well, I'm going to make this be exactly like this. I'm basically just going to divide by 2. Then sine x cosine x equals 1/2 sine 2x.
Oh, look at that.
We okay with that?
Yeah.
Show of hands if you're okay with that one. Well, what that means is, hey, look at that. I can make it sine x cosine x to the fourth. Of course, this is a special case, okay, where they're both exactly the same power. If they're not exactly the same power, then naturally this won't work. But I want you to see this at least once, where they're both the same power. You got me?
Yeah.
So we can do this, okay. Then this piece is 1/2 sine 2x. So our integral is integral of 1/2 sine 2x all to the fourth power dx. Y'all still okay?
Yeah.
You sure? Let's keep on moving. What's the next thing that I need to take care of?
Make substitution.
The one, I don't want, I know one.
I don't care really about this u substitution, I really don't. Because it'd be very trivial, u equals 2x, you'd have a 1/2, sure, don't worry about that. We can do that basically in our head. What I'm worried about, and we're going to be changing things, so if you do a u substitution on this now, you're going to have to do it later again too. So don't worry about it until the very, very end when you're actually evaluating integrals. Does that make sense? Don't worry about it right now. What I do want to get rid of is, this looks kind of nasty to me. Can I take this to the fourth power and this to the fourth power?
Yeah, you can.
Okay, let's do that. So I'm going to have the integral of, what is 1/2 to the fourth power?
Like 16.
You know what people do when they're just learning this, or when they're going too fast on a test or their homework, is they'll forget about this guy and they'll give me 1/2 again. Do you see how common that might be? When I'm grading papers, I see that a lot. Where are they getting 1/16 from? I'm getting 1/2 all the time, my goodness. Well, you might not be taking that to the correct power. So be careful with this stuff. This whole thing is being raised to the fourth. Now, if you understand that concept. Okay. Okay, then I've got sine to the fourth power of 2x dx. Looks a little bit nicer. What's the next thing I'm going to do?
Move on to that constant.
1/16.
For a while now. It's a space where nearly 1,500 people show off their fabulousness. We talk about anything you could imagine and a lot of things you couldn't. You can take on anything with Facebook groups. More together.
Integral sine to the fourth 2x dx. Now, stop for a second. If you were so inclined, thinking about what I taught you back in the last section, what could you use here?
The reduction formula.
You could use the reduction formula. It would absolutely work right now. Do you guys see why?
Oh, yeah.
It's, well, there's no y, I know. But there's a sign. Look at the sign. It's to the fourth power. That power is greater than 2, greater than or equal to 2. You could use reduction formula right now. In fact, we did sine to the fourth in class just like 2 days ago. Remember, well, 2 days ago you took your test, but 3 days ago. You remember doing that?
Yeah.
It was the last thing we did. You could do it right now. You can just make a substitution. This is where you do it. U equals 2x. du over 2. This would be 1 over 32. You got me? Then you got sine to the fourth of u du. And you do reduction formula like, I think it's 2 times. You do reduction formula twice. And you'd be done with this thing. Do you guys get what I'm talking about? Look back in your notes or watch the video from the last section if you don't remember how to do reduction formula. Now, what if you don't see reduction formula? Is there another way to do it? And the answer is yeah, which is really interesting because what's going to happen here is we're going to get our integral evaluated and it's going to look different than if we had done this with reduction formula. Reduction formula will work. It will be equivalent, but it's going to look different. Does that make sense? Now, I don't care how you do it. If you see this, I've already taught you reduction formula, right? You can do it. That's fine, anytime. If it's sine to some power, go for it. Some of us have, a few of you have proved the reduction formula for cosine. Go ahead and use it. Your answers are going to look a little bit different than if you do it this next technique. So, technique 1, you work it all down, you go, hey, I see reduction formula, I can do that. It's sine to a power greater than or equal to 2. No big deal. Remember that one? It's the 1 over n, and you know, sines and cosines and a minus and 1 over, n over n minus 1 over n integral, and it reduces it for you. Well, let's say you don't see it. Is there a different way? And the answer is yeah. If there's not a reduction formula possible, or you don't see it, we can still do this with those half-angle formulas. And here's how you'd work it. Instead of thinking of this as sine to the fourth power, what we need to do is we need to find something that will allow us to make this substitution. this, basically. So when we get down to here, we go, man, how do I do it? Reduction formula. If you don't see reduction formula, so how we're going to rewrite it is 1/16 integral. Let me rewrite sine to the fourth power. How am I going to write it as something?
2x times sine squared 2x.
I'm going to change what you said just a little bit. I want sine squared 2x to some power. What is it?
Squared squared.
You all right on that one?
Yeah.
Now, as soon as you do that, as soon as you go, well, wait a minute, here's some even powers. I know I'm gonna be using half angles somewhere, unless I do reduction formula that works out that nicely, we can do that. But if we can't, then we're gonna have some sort of a half angle formula coming up somewhere, and here's where we go with it. So from here, we still get a 1/16. Sine squared, let's do sine squared 2x, let's make it into the cosine. Here's why we do it. If we take sine squared and we change it to 1/2 1 minus cosine, maybe you don't know why we're gonna do this. What's the power here?
2.
What's the power here? The power for you. Does that make sense?
Yeah.
You can do the integral of cosine to the first power. You can't do the integral of sine to the second power the way it is. You need reduction formula, or you need to make the substitution. So we're going to do that. Use the identity. Now let's be real careful with this. Don't lose your stuff. What's the power going to be up here?
2.
Okay, and then inside, let's do that. What's going to be?
1/2 parenthesis 1 minus cosine.
1 minus, okay, I like that. 1/2, 1 minus, and then cosine for sure. Now, be very careful. Don't lose pieces of this thing.
2x.
It's not 2x. Explain why is it not 2x? What's the argument of our sine function here? And this says whatever your x is,
Alpha is 4x.
whatever your x is, you're going to multiply it by 2. So if we have x, yeah, it's 2x. If we have 2x, it's going to be
4x.
Do you see how common of a mistake that's going to be for some people in here?
Yeah.
Okay, don't make that mistake. Because then when you do your substitution, you'll have a 1/2 when you should be having a 1/4. Does that make sense? Or a 1/8 or something. So this is going to be 4x. Be careful with your math. Show of hands, feel okay with that so far? Good deal, okay. Now what? Goodness gracious. Well, if we're doing it this
How
way,
do you do substitution?
we can't do a substitute, because if we substitute for cosine, is there a sine anywhere to be had? We can't do it. The only thing we can do here, distribute all this junk. So what I'm going to do, same thing I did here. I took 1/2 to the fourth. We're going to take 1/2 to the second. How much is that going to be?
1/4.
So I've got a 1/16 out front already. This is going to give me a 1/4. Don't forget about that, guy. You need that. So 1/4, you know what I need that for.
I'm in a Facebook group called Houseplant Hobbyist. People post stuff like, can you guys help me save my plant? But you also see people sharing vulnerable things. And it's always surprising, but in the very best way. You can take on anything with Facebook groups. More together.
hope you follow the notation. Here, all we did was we took 1/2 squared, it's 1/4. We took this thing, now this thing, I think I missed one there. Now it's this thing squared, 1 minus cosine 4x to the second power. Quick head nod if you're okay with that one. Can you guys distribute this? Are you just going to square this and square this? Please, for heaven's sakes, don't do that. Remember that what this means is 1 minus cosine 4x times 1 minus cosine 4x. Would you please spend some time and distribute that for me? Go ahead, distribute that for me.
Tonight, I'll be eating loaded tots for March Madness. Thanks, boo. I think you better double them tots. No, this me was last year. I didn't get my madness last year, so we're doing double the madness this year.
What I'm going to do is I'm going to pull the 1/4 out front. We have a 1/16. We now have another 1/4. What's 1/16 and 1/4? How much are we going to get there? 164. Then what? So this now combines for 1/64. You guys are distributing this right now for me, so hopefully you get this. It's usually not very hard. You guys know how to FOIL. This is 1 minus 2 cosine 4x plus cosine squared 4x. How many people got that? Perfect. That's what goes here. Let's take a real close look at our integral and see what we got going on. If I asked you to, could you do the integral of 1? Yeah, no substitution, that's a piece of cake. Could you do the integral of cosine 4x? Yeah, what's the integral of cosine? Now, you'd have a 4x, so that'd be over 4. You'd need a little substitution. I typically do those in my head. U sub on that would be over 4. Does that make sense to you? Now, can you do this one? Okay, let's try this again. Integral of this, could you do it? Easy. Integral of this, could you do it without a substitution? A little substitution, but that's easy. Can you do the integral of cosine squared? Is that anywhere in your integration table?
No.
We got to go over again. So we start from the very beginning with our trig stuff. What power do we have? Odd or even? Even power. With even powers, we use what? Pythagorean identity or half angle. Which one? Do we know a half angle for cosine squared?
Yeah, we do.
Then that lets you break that down again. There's lots of steps here. Lots to this. Be very careful. Write these all out. I know some of you don't like to write steps, and I'm going to say, too stinking bad. Do it anyway. You got to write this. You got to be able to do this. And make no mistakes on it. So we have 1. We got minus cosine 4x. We've got a plus. Let's look inside here. Remember that cosine squared x equals 1/2 1 minus cosine, plus cosine 2x. Hopefully we're familiar with that one. Let's apply it here. I've got the 1, I've got the minus cosine 4x, I've got the plus. What am I going to write next? 1/2. Got it. Keep on going. Come on, tell me.
1 plus cosine 2x, but don't forget the press.
Oh, 8.
Okay, now,
8.
you all need to be careful on what the argument of that thing is going to become. Listen, we're starting with cosine squared of 4x. If cosine squared x gives me cosine 2x, cosine squared 4x gives me cosine... Remember, you take your argument, you multiply by 2. What is it?
8.
Perfect. I'll tell you what, we're almost done. I want to do about a 10-second recap to make sure you guys are good with this stuff. You okay with the making it all do the fourth power?
Yep.
It's a special case, and I get that. You're not always going to have the same power there. But when you do, man, try something like this. It's kind of nice. Use an identity. Are you going to have to know your trig identities? Yeah, otherwise this stuff doesn't make sense. You got to have that down. People take Calculus 2 to finally fail trigonometry. People take Calculus 1 to finally fail algebra, all right? But this is trig. I mean, my goodness, we're going to use a lot of trig. Then we go, okay, well, that's cool. You know what? We can just take it all to the fourth power. We recognize this one as either a reduction formula that we could do, which probably would be a little bit quicker than this, to be honest with you. Sometimes you won't be able to do reduction formulas, sometimes you will. Or we go, well, I didn't remember that, so let's practice doing the whole even power thing. The even power thing is make it a sine squared or make it a cosine squared somehow. Then use a half angle. Cool. Then distribute it. Look for any more squares. You're basically reducing this with the half angle formula. It's like an inherent reduction formula. The half angle formula always reduces your power. Do you get what I'm saying? So we look again, we go, okay, well, we got to do it one more time. Half angle again, reduces the power one more time. Now we have everything to the first power. We got 1, no big deal. Cosine of the first, we're going to distribute this in just a bit. Cosine of the first. Let's pretty this thing up a little bit. What are you going to do here? Let's do it. We want to make our integral as nice as possible before we actually integrate. So we got 1/64. We're going to have 1 minus 2 cosine 4x. Don't lose track of that 4x. Plus 1/2 plus 1/2 cosine 8x dx. Okay, I'll tell you what. Whenever you distribute in algebra, the one thing that you should probably do after you distribute is check for what? That's right, like terms. Do we have any like terms here?
Yeah.
Yeah, just combine those numbers. This is 1 and 1/2, that's 3 halves. That'll make you integrate one less term here, which is kind of nice. Combine your terms if you have any. Can I combine cosine of 4x and cosine of 8x? No. That's a no-no. So 1/64, we got 3 halves minus 2 cosine 4x plus 1/2 cosine 8x dx. My goodness, that's a lot of junk. I want to make sure that we're all good to go. Do you guys feel okay on what we've done so far? Yes, no?
Yep.
Okay. Can we integrate that little piece?
Yes.
This one? This one? The same thing. It's integrated. When you do it, just be real careful with your constants. That's typical. I mean, almost nobody gets the integral of cosine wrong. Oh no, it's sine. It's the constants that are going to get you here. So don't lose track of stuff. We're going to have 1/64. We're going to have a big old bracket here. Let's integrate piece by piece. Integral of 3 halves. 3 halves x. Very good. Minus, here's how integrals work. If you want to do these in your head, this is the way I do it. I do little substitutions in my head because I don't want to waste my time. So watch. Watch. Here's what you do. The 2 is a constant, correct?
Yeah.
Integral of cosine?
Negative sine.
It's sine 4x. What's the derivative of 4x?
4.
Over 4. That's how you do it. So derivative of this thing, that's a basic substitution when you just have constants. It'll typically work with those arguments. You should put it over whatever the derivative is. If you notice, this is coming from the du over 4 that you would get. Does that make sense? So that's where that's coming from. Let's try the next one. What's the next thing I write?
1/2
Next thing.
sine 8x
Sine 8x.
over 8.
Perfect, over 8. Now we're able to do those without actually having to write a special substitution on that, because that takes a little while, right? You have a substitution here, you have another substitution here, that takes some time.
Can that 2 and 4 cancel out?
Well, we're going to talk about that right now. I want to make sure you guys are good on this so far. Show of hands if you are. Okay, so yeah, a few things are going to happen. Of course, we're always going to look at simplifying. 2 with 4, done. This becomes what?
16.
Okay, and then maybe we'll distribute. Maybe you won't. It kind of depends. I'm going to distribute because I want to. So we'll have 3 over 128x. Oh goodness. We'll have minus, when we distribute, notice this is a 1/2.
Yeah.
1 over 128 sine of 4x plus Wow, what's this gonna be? So basically you have 64 times 2 times 8, or 64 times 16. I don't even know. You tell me what it is.
1024.
Sounds good. I'll take your word for it. Sine 8x, and finally,
Plus C.
plus c.
1000.
Wow. Wow, that was a lot of work.
Shows the bad.
Could you have left the 64? Absolutely. No problem. You could have just left that factor. You could factor out something else. Steve, question.
Totally should have just factored out a 1/2.
Yeah, you could have. Could have factored a 1/2 and made it 128 and then 3x. Should have just done reduction formula. That's right. But you know what? There's times when you can't, right? So I want to get you really practicing this. The next one you see that we're going to be able to do that as well. But I want to see you practicing this method. Does that make sense to you?
Yeah.
So I get it. The reduction formula works. That's what I would do. Notice that this is going to be a little more concise than the reduction formula. Reduction has sines and cosines in it. So this would be a little bit nicer in my opinion, but you could do it with reduction formula. Are you guys ready for the next one?
Yeah.
Okay, the next one's going to be some work. Question?
If we were to use the reduction formula, is it possible that we could get something that looked different but was equivalent to that?
That's actually just what I was saying, is that when you do reduction formula, it's going to have sines and cosines. The integral will be equivalent, and you can get the same thing with identities, but it's going to look different. Okay?
Well, how can you know it's the same thing?
You do the identities to prove it. Like all those times in trig where it said, prove this identity. That's how you do it. That's why they had you do those. That's why they had you do those. So anyway, let's continue. Let's do this one.
Integral sine, easy.
Hey, there's no dx there, so I drew this one wrong. You just say, can't do it.
Hey guys, does this day sound familiar? You go to a confusing lecture, you ask for help.
Oh yeah, did you have any questions on that? We're good.
Okay.
Just watch the video.
That's right. Watch the video again. Hey, there you go. Questions? Too bad. Just joking. Let's make this sine to the 6th dx. Now, what would you use here?
Reduction.
I would use reduction formula. What if you didn't know the reduction formula, forgot it, just missed it, or just want to practice like I do on doing it differently? Can we do it?
Yeah.
Of course we can. Is it going to take a lot of work?
Yeah.
Yes, it is. So, how would you do it if you didn't have the reduction formula?
Sine x to the 6th power.
Sine of x to the 6th, you're close, but no. You see, if I have even... Let's look at the powers. Look at, do I have odd powers?
No.
I actually have 2 even powers. If you don't think there's 2 of them,
you
kind of.
two odd?
Cosine is 0, so it doesn't really count, but I have sine to the 6th power. That's my only power. It happens to be even. So, what are you going to use, ladies and gentlemen, when you have all even powers? Will you use Pythagorean theorem or half angle? Half angles. So we need to make this a half angle. Half angle only works if you have sine squared or cosine squared. So somehow I want you to rewrite that with a sine squared. Go for it. And don't write out sine squared times sine squared times sine squared, okay? You could, I guess, but it's going to be the same. But it just looks sloppy. How am I going to write out sine to the 6th power as sine squared to something? Did y'all do that one?
Yeah.
Okay, I want to see if you understand the reason why we just did that. What are we trying to use when we have even powers? Even powers only work when you have sine to the second, or cosine to the second, but we don't have any cosines. So that's the only thing that's going to work for us is to do sine to the second and then do the 3rd power. Are you guys with me?
Yeah.
Do the next step. Can you use the half angle formula here?
Yeah.
Do it.
Cosine 2x.
Let's see if y'all got it. Did you get 1/2 times 1 minus cosine 2x and then all of that raised to the 3rd power with a bracket?
Yeah.
Cool. Next thing you're going to do, let's do it. What are you going to do?
Just read that exponent.
Yeah, you are. This is going to become how much?
1/8.
1/8 is going to be pulled in front of my integral. You follow?
Yeah.
Now, what do you have to do with this thing?
Just keep it that way.
I know I forgot something, sorry. You're going to have to distribute that.
Oh,
So
yeah.
if that was to the, Oh my gosh, if that was to a higher power, you'd have to distribute even more. So yeah, you have to, if you're going to do this method without reduction formula, you actually have to distribute that. So on your own right now, off to the side, do 1 minus cosine 2x times 1 minus cosine 2x times 1 minus cosine 2. You're going to have to distribute that. I'll let you do that for about 10 minutes. I'm right on the board here. You're welcome. I think that's right. You want to check? There are easier ways to do binomial expansion. That's one of them. If you know the Pascal's triangle 1, 3, 3, 1, and you know alternating signs with a minus, minus, plus, minus, and you know powers reduce powers gain 0, 1, 2, 3. You can distribute things like that very quickly. Very quickly. So if I did like to the 4th power, basically it'd be the same. It'd be 1, 4, 1, 4, 6, 4, 1. And then you could, if you know the binomial expansion, you can do that. So anyway, this is what you should have if you distributed it and combined like terms. Did you all get that?
Yeah.
Are you just going to trust me that that's right?
Yeah.
Probably. Okay, that's right. Let's continue. Now look, after you distribute, after you do that, you really do got to look at your problem. See what's going on here, folks. Check this out. Can you do the integral of this?
Yeah.
Then you're going to leave that. Don't bother changing that. That's a good thing. Remember, you could separate this into 1, 2, 3, 4 more integrals. We're not going to. We're going to do it in our head. But you could. So leave this alone. Leave this alone. Can you take the integral of cosine?
Yeah.
Leave that alone. Can you take the integral of cosine squared?
No.
So this is something we got to work on. Okay, let's see if you're paying attention. With cosine squared, would I use Pythagorean identity or half angle?
Half angle.
Why?
Because it's cosine to the square.
Bam! That's exactly right. So this is going to be a half angle right here. Now stop. We're going to do one more thing. Cosine to the 3rd. Can you do the integral of this right now?
No.
Change that one too. So this is another one. That's an ugly little star, isn't it? Another little star. If you got cosine to the 3rd, okay, let's think about this. Are you going to do half angle? Or are you going to do Pythagorean identity? Why?
Because it's an odd.
Odd. That's right. That's exactly right. So let's go slow. I want you to just do the half angle right now on this guy. Just do that. Let's see, 3, that I know this thing is 1 plus cos, let's see if you got it. This part right here is 1/2, 1 plus cosine.
4x.
Brilliant, 4x. Did you all get the 4x? Good. Minus. Let's talk about this one now. If I've got cosine cubed of 2x, you're right, that stands for, that's an odd power. So what do we do with odd powers? Pull one off. Very good. We strip off we get the stripper. We get the stripper. That's right. So we strip one off here, cosine 2x dx. Oh, look at that. We're going to do a couple things at once, okay? So don't get lost on me here. I'm going to leave all this stuff the same. I'm going to distribute this, because that's nice. We want to distribute that. I'm also going to start changing this guy. Show of hands if you feel okay with this so far. All right, so we've got a 1/8. We've got an integral. We've got a 1. We've got a minus 3 cosine 2x. We've got to check this out. This is 3/2 times 1 is 3/2. 3/2 times cosine 4x is 3/2 cosine 4x. So this is exactly the same. All I'm doing is distributing 3/2. So we got those two pieces. Quick head knock right with that one. Now, when you're working with this stuff inside of an integral, you can do two things.
What is a half angle?
You can do this if you want to. You can go, wait a minute, this is too confusing for me right now. I don't want to deal with this here. You can write a dx and split off another integral. Does that make sense?
Yeah.
Do it off to the side. Just don't forget it's a minus. You're going to have a bracket around all the junk that you do right now. Does that make sense to you?
Yeah.
You can do it in here too and do the substitutions and or distribute and make things a little bit nice for you. That's what I'm going to do. So either you're doing this off to the side, no problem, or you're doing it the way I'm going to show you. You guys okay with this so far?
Yes.
Okay, so this is like its own little problem right here. Here's how I would choose to do it. I say, okay, well, you know what? This right here, this is the same. What are we doing here? Are we doing half angle or Pythagorean? Because it's connected with this, you do half angle. So again, you would have this integral. So Pythagorean off to the side if you chose to do it. This would become 1 minus sine squared. You want Pythagorean, not half angle. That is cosine 2x. That's supposed to be a little 2 there. And then you do a simple substitution, and you're practically done with that. You guys okay with that one? Okay, maybe I'll do both, just so you see that it works out the same. Over here, what would your u become? Cosine or sine? Sine. It's usually inside of something. Sine of what? du. Those people who hate to do the chain rule don't mess this up. What's this going to become? Or du over 2 equals cosine 2x dx. Exactly what we have here. Therefore we get, I know I'm working quickly, but we've already done something very similar to this. This is 1 minus u squared. This guy is du over 2. Or in other words, this is 1/2 integral of 1 minus u squared du. 1/2 u minus u cubed over 3. One half u minus 1/6 u cubed. And lastly, we do our substitution back in. We'd have 1/2, what was our substitution anyway? Minus 1/6 sine cubed 2x. Okay, I know I did it fast, but I want to know how many people could do this on their own at this point. It should be pretty much all of you, because we all know how to do a substitution. This was the only big thing, is seeing. Just really, have you noticed how the hard part about this is seeing what to do? It's not actually doing it. It's going, oh wait, I got a cosine cubed. Is that half angle or is that Pythagorean? It's odd, so it's Pythagorean. This was even, therefore it's half angle. So, well, separate it so that you can do Pythagorean. So cube, no. Strip it off. We've got Pythagorean, we got that. Pythagorean identity, do a little substitution. It works out pretty nicely. Show of hands if you got the same thing on your own. You're okay with that one. Cool. Now, notice something. This integral is done. So this is what you plug back in right here when you're done with the integral. Does that make sense?
Yeah.
It'd be minus this whole mess of crap. Now, if you do it the other way, I don't even know if I want to show you the other way now that we've already done it. Take some time. If you do it the other way, basically you just put a bracket here. You do the same thing, sine squared 2x, cosine 2x dx. You would distribute it. So you would have a cosine 2x here. I would probably combine that cosine 2x somewhere over here. And then you'd have the same substitution that you just did. Does that make sense to you? So you can do it one or the other way. I'm going to leave that. So I like that way. I like doing it off to the side. So this is going to be minus this stuff. 1/2 sine 2x minus 1/6 sine cubed 2x. I'll put the plus c on the very end of my problem. I don't need to deal with it right now. Okay, so I don't want to lose you. I don't want to lose anybody. So let's check it out. You guys are okay down to here, correct? This one, we said, no. let's separate this. Let's call this one big fat integral. That's why we got the dx right here where there wasn't one before. Then we're subtracting the integral of this guy. So we said, now let's make this a dx and we'll have the integral of this. So we move that over here. We do it off to the side. It's a problem within a problem. So 1 minus sine squared 2x times cosine 2x. Do the integral, then put it right back. We get the same thing. So are we going to integrate this right now? Heck no. Are we going to integrate this stuff right now?
Yes.
Of course we are. What might you want to do before you start integrating that?
Combine all terms.
Yeah, that's right. And in fact, if you would have done this the other way that I was about to show you, you would have some more like terms to combine. So you'd have less terms. It's whether you want to combine them now or combine them later. We're going to do it at some point. What like terms do we have?
We have
1, 2, 3 halves. How much is it? 5 halves. So this is going to be 5 halves. So 1/8 integral 5 halves minus 3 cosine 2x. This is gone. Plus 3 halves cosine 4x. Notice dx. Calculus ends here. This we've already done. Distribute. Yeah, you can do that. You could distribute that right now if you wanted to. You want to do that?
Yeah.
The negative.
So minus 1/2 sine 2x. Good. Plus 1/6 sine to the 3rd power 2x. Now let's work on the integral of this thing. Almost done.
You're forgetting the dx on both of those.
What dx?
The whole integral
It's right there.
for the other one.
The last
Top.
is already,
There's a hit.
it's already integrated.
Oh, you split it?
That was kind of the whole idea. Was right here we split this and we did this integral separately. That way we could use substitution and go, yeah, you know what? Let's do this separate. We have it back in terms of x. Now we can put it back. So this was all one integral. This one I said, no, this is too hard for me to do right here. Or you actually could, not a big deal. Or you could do it separately. I just want to give you that option. So either way, and I don't care how. Pull that off. Make sure you get all the way done. Then you plug it back here. But notice, we've already done the integral. There is no more integration to do here. I really do need you to understand that. Show of hands if you do. You feel okay with that. Question? Someone looked like they had one. Question? You sure? Okay, almost done. So 1/8 times some nasty stuff. Let's do this integral. Can you do the integral of 5 halves?
Yeah.
What is it?
5 half x.
Minus. Be very careful with these guys. This is going to be minus 3. Integral of cosine 2x, please.
Sine of 2x times 2.
No, it's not times 2.
Divide by 2.
When you're doing integrals, you're dividing by this derivative because you're setting this equal to u, derivative of this equals du, so dx would equal du over the 2. Plus 3 halves. Let's try this again, okay? Derivative of this one?
Sine 4x.
Perfect. Again, you're kind of doing those substitutions in your head. Minus all this stuff. Oh dear. It's fun, right?
A little bit.
What now?
Distribute to 1/8. And combine that.
So working from the very bottom, 5/16 x. Oh goodness, minus 3/16 sine 2x. I know, right? 3 sine 4x. Minus 1/2 sine 2x plus 1/6 sine cubed 2x. Oh goodness. All right. Well, almost done. What's the last thing that we're going to do?
Wouldn't you have to distribute the 1/8 on both sides? We did. We're gonna be 8 times 8. So- 16.
No. It also goes here. Yeah, you're right. This is a big bracket.
Oh, yeah.
Yeah, you're right. You're absolutely right. So if I distribute that, what's this change to?
So 16.
Yeah.
And 40.
How much?
48.
There's only one more thing we got to do. We're looking for any like terms. So like terms, do you see any?
The sine. Oh no. The sine 2x. Yeah.
This one, no. This one, yes. These two are like terms, and thankfully, because Patrick caught this, we distributed that, and they have a common denominator right now, which is really nice. So we're going to have, I was just testing you, Patrick, you passed. 5/16. How much is that going to be?
4/16, so it should be 1/4.
And lastly, let's see. Okay, I want to show you one more thing with this. If you didn't do the integral, so I do want to prove to you that it does come out the same. So imagine you didn't do this right here. What you'd have is 1 minus sine squared 2x times cosine 2x, all dx. You'd have a minus cosine 2x plus sine squared 2x cosine 2x dx. You would distribute this thing. This is what you would combine with this thing. It would be minus 4. So when you look at that, this would become minus 4 cosine 2x. If you do the integral of the minus 4 cosine 2x, you'd get minus 4 sine 2x over 2. Correct? That would be the 2. You get 2 sine 2x. When you multiply by 1/8, you get the 1/4 right there. Does that make sense to you? It matches. The coefficients are going to match. So this one would get combined with this one right now. This one is what you do over here. You do the u sub on sine. You get du equals 2 cosine 2x dx. You get du over 2 equals cosine 2x dx. This is what would match right here. It'd be a little substitution kind of off to the side. And what you'd end up getting is you get u squared over 2. Does that make sense? U squared over 2. So when you do u squared over 2, check that out. U squared over 2 would give you u to the third over 3 times 2. That's 6. 6 times the 1/6. 1/6 times 8 gives you the 148. Here's the u to the third power of the sine 2x. Oh my gosh, that's a lot of work. Either way it works. I just want to prove to you that it actually does. Show of hands if that one made sense. Okay, that's hard, right? What would be way easier?
Not that.
Reduction formula would be easier, but if you don't have it or you can't use it, then this is what you have to do. So, what you should know at this point, odd powers. Odd powers, you use which identity, please? Everybody. Pythagorean. Odd powers, Pythagorean. Even powers. Very good.
For those who have found themselves without health insurance, sign up now at healthcare.gov. 3 out of 4 customers can find a plan with a monthly premium of $50 or less thanks to financial help. Sign up at healthcare.gov now through May 15th.
All right, let's do our last example about integrals that involve sine and cosine. After this, we'll talk about some other